Okay, today I'm going to be talking about putting privacy on the map. So kind of trying to go beyond compliance in organizations and see that how we can practically do some of the privacy threat modeling and like apply some of the privacy threat modeling frameworks that we have seen. So let's see. Okay, so for MAP or models of applied privacy, we kind of take a developer-centric approach. So rather than asking like legal teams that what we can do, we ask developers that, okay, if you're a developer, you know how your application works, you know what kind of data it collects, then how do we find out that, okay, what are the different threats, privacy threats that can happen in my application? So the simple way that we do that, which most of you are familiar here, is by doing a manual privacy threat model, so that we can identify that, okay, these are the kinds of threats that can happen to my application, and we review like architecture diagrams and things like that to learn more. However, like when we do a privacy threat model, it typically happens late stage at an application. If you don't have like a mature privacy program, it typically happens later after an application is developed. It's resource intensive, so you need privacy engineers, you need operational people, so who can speak for like what are the privacy threats. We need a common language, so when we are talking about like an organization where there are so many different kinds of applications with completely different use cases, we need a common language to understand that, okay, these are the privacy threats that can happen. And consequently, that requires a degree of privacy expertise. So what we want to be able to do, the problem that we are trying to solve, is integrate privacy early into the process so that developers can find some of these privacy threats on their own, and build a common language, so make it general enough so that no matter what kind of application it is, we can still have a common language for privacy threats. And the way we do that is by using terms that are already established and familiar. So we don't reinvent the wheel here, we use existing frameworks, which I'll just shortly talk about. But the way we approach a privacy threat is by creating a fictional persona who is doing a problematic action and creating some kind of harm. And that leads to like a privacy finding for an application. So some of the existing privacy frameworks that we look at are the OWASP top 10 privacy risks, the MITRE privacy threat modeling, threat taxonomy, NIST PRAM, privacy risk assessment methodology, and Linden. So what we do here is basically we are trying to combine these different frameworks to create like a holistic process that people will be able to use to either risk rank existing privacy findings that they have done in previous threat models, or find new privacy threats to their application. So basically there are three components to map. So you have the threat actor, which we developed from CSA in threat actor library, and we classify it. There is a threat mechanism, so which we derive from Linden and the privacy risk assessment methodology. And then we have impact, which we derive from Solov's taxonomy of privacy harms. So how does the threat modeling framework look like? So the first component of this, and which pretty much forms the core of it, is the threat mechanism, which we derive from Linden and PRAM. And we talk about different kinds of threats that can happen. So linkability, identifiability, non-repudiation, things like that. And then the second component that we discuss is who can cause this threat. So depending on who the threat actor is, the impact of the threat significantly changes. So are they present inside so basically threat actors are classified into 4 major categories: inside aggressive, inside neutral, outside aggressive, or outside neutral, depending on whether they intend to cause harm to an organization or not. And depending on whether they are present inside or outside an organization and what their expertise level is, it can determine what threats they can cause and what access they have to an application. And the final component of this is threat impact. So is that harm related to an organization or to a person? So who is it affecting determines like the scale of impact. And if the harm is measurable or not. So in each category we kind of divide it up into organizational an individual, and then explicit and implicit based on whether we can measure that harm or not. So this is what the combined framework looks like. So we take a combination of threat actor, mechanism, and impact to come up with a finding. So for example, a related entity could take could have like a threat, like identifiability threat, and cause corresponding threat impact. So the advantages of having this combined framework is that it makes it's flexible, it's easier to add or delete categories. So like we were talking about the different existing frameworks, we can take any framework and swap it out for the list of threats that we have. It's scalable, so no matter what kind of application you have, it would be applicable to that. And it moves away from an attacker-only approach. So whenever we talk about threats, and as like the talks before we're discussing this, that like not all threats come from malicious actors. A lot of these threats come from actors who do not intend to cause harm. It's accidental harm that happens, accidental privacy harm that happens. So how do I use maps? So maps use personas to go from abstract to concrete visualization of threats, and personas are something that developers are usually familiar with. So how do they practically use this is security threat models are usually like the first step that they complete, and then they review the application. So whatever application they want to threat model, they review it, they review the map categories, and they select relevant subcategories for them. So for example, if it's not a customer facing application, so that is a threat actor they wouldn't consider, or like similar, like something like that. So and then they select one category from each of the components to create a persona and then apply it to their system. They work, this is a very collaborative process, so they would typically work with a threat modeling team, like the product team would work with a threat modeling team to determine which of these are applicable for them, which of these they can mitigate, and what steps they would take to mitigate those. So let's do an example. So let's say April is a user who uses a social media application. It's very pared down. So this is April for parks and recreation fans. So let's say they use the social media application through like the computer or their cell phone, and all of that goes into a combined profile database where they have profile tags, behavior tags, website cookies, etc. And then from that profile database, let's say it goes to a basic ad delivery network, and the ad delivery network, based on like they run some kind of analytic and deliver ads back to the website or mobile platform. So let's take like a first persona. So this is like a broad representation of like what the persona could be. So in this case, it would be that let's say from the website there is April sees that from the website when the data is going to the profile database, a lot more data is being shared than what was said in the like what they had consented for. So we could ask some of these questions like, have you documented all of the data types collected? Is your application collecting only the minimum data necessary? Have you told your consumers like what kinds of data that you're collecting? So does April know in this case that what data is being collected? So your threat actor becomes researchers who are trying to find issues with this application, and they find that this is non-compliant. So then what developers do is they work with threat modelers to determine that what are the different steps that they can take to mitigate some of this. So maybe having an audit process for databases to ensure that the data is being minimized, they are not collecting more than what they have said they will collect, and retention policies are in place. So if the profile database suppose contains certain amount of data which they are supposed to store for 30 days, they are following necessary policies. So another example could be where the threat actor is an employee and the threat mechanism is identifiability. So let's say Avocado is a developer at a learning solution. They have a public database, but it contains some kind of personal information. So for example, let's say in this profile database, in this example, it contains like one of the columns may contain links, and those links might take to, like, say, some kind of social security numbers or something like that, that they store via those links. So some of the questions that you can ask during the threat modeling session are like, does your database contain links? Do they redirect to any sensitive information? And if they do, what kind of authentication mechanisms are in place so as to limit access to this information? So some of the ways that this can be mitigated is like having the amount of information that is available in a database on a need-to-know basis. So whoever is accessing that database, we have to make sure that they are authorized to access that information, and they receive only that is required for them, and minimize the amount of information that is viewable. Another example of a privacy threat could come from related entities. So related entities would mean vendors or other third-party stakeholders in the company, and a threat mechanism could be unawareness. So let's say that in this case, like this social media application is sending ads to this ad delivery network, and they happen to be a third party, then like we need to make sure that those privacy controls are in place when this information is being shared with that third party. So an example persona here could be, say, Mango provides identity verification services as a vendor for the social media platform, but during a breach they find that this information is shared with this third party to verify their account, but they also send this data to a marketing company, and where, like in this example, they're getting all of these ads from that company. So that's a privacy issue. So some of the questions that you can ask during a threat modeling session is that, does your application has a vendor who uses customer data beyond their functionality? So do you need to send that data? And if you're sending that data to a vendor, what is the use for that application? What is the use for that data? And can customers limit their data from being shared with vendors? If they do, are they able to access or modify their data, or select what kinds of data that they are sharing? And has the vendor gone through third-party security assessments? So do they have security controls in place to handle this kind of data? So some of the mitigations, this is like not an exhaustive list, so some of the mitigations could be like being transparent with customers, so informing the users and giving them control to delete their data, to make sure that whenever their data is being shared with a vendor or any kind of third-party services, their data is not being is handled properly. So these are some of the ways that we can ensure that like we have these privacy controls in place, and these findings that come up during a threat modeling session are mitigated. So now that we know that, okay, this is how we use MAP and we create personas, we asked if we can show a use case of real-world incidents as personas using MAP. So what we did is we tested this model against the Verizon community database for 207 privacy-related incidents. So note that there can be multiple threat impacts for each of these privacy incidents, but from our sample of 207 incidents, we found that 183 incidents match this framework category. About 24 did not match, so that's around 11%, and that's because like they did not have enough information about the mechanism of threat. So what we did is like classify these incidents and then see if the categories in MAP could be used to categorize these incidents. So if you look at the graph, this is the highlighted part is only 80% of the 183 incidents that we classified, and we show a breakdown of actor, mechanism, and impact. So the highlighted numbers show that some categories that sum up to 80% of the incidents, and if you look at the actor category, employees and related entities form about 80% of the breaches. So they are not malicious actors. Most of the privacy breaches are caused by non-malicious actors. So, and mechanism, the three most common mechanisms were non-compliance, disclosure, and identifiability. and impact was autonomy harm, so people did not have control over their data, reputational harm to both the organization and the and individuals. So thank you for listening. I just presented like a unified way to kind of think about and discuss privacy threats using personas, and you can use MAP to classify your existing threats as well. So we have our open source project on GitHub if you want to go there and take a look at the different threat categories, learn more about it. It's available at github.com/comcast/map. And you can find more information about our team or reach us on LinkedIn. So with that, I'm happy to take questions.